140 million miles away. A dead, frozen, red desert of a planet. Now imagine loading up every nuclear weapon on Earth, over 12,000 of them, and firing every single one at Mars, all at once. Would we blow a hole clean through the planet? Would we turn it into a second Earth? Or would something far stranger happen? Let's get the numbers straight first. Earth's combined nuclear arsenal is roughly 12,000 warheads, with a combined yield well over 1,000 megatons. That's tens of thousands of Hiroshima bombs worth of energy. Mars, meanwhile, is about half the diameter of Earth, with barely any atmosphere, less than 1% the pressure of ours, and it's cold enough to freeze carbon dioxide solid at its poles. So the question is simple. If you took the most destructive arsenal humanity has ever built and threw it at an entire planet, what actually happens? The honest answer? Less than you'd think, and for a very specific reason. Here's the number that changes everything. Mars has a mass of about 640 billion tons. Even the largest nuclear weapon ever tested, the Soviet Tsar Bomba, released roughly 50 megatons of energy, and that was still just a firecracker compared to the natural forces that shape a planet. Multiply that by every warhead on Earth, and you get an enormous amount of destructive power by human standards, but by planetary standards, it's a rounding error. For comparison, the asteroid impact that's linked to the extinction of the dinosaurs released energy equivalent to billions of times more than our entire global nuclear arsenal combined. That impact reshaped Earth's climate for years, and even that didn't crack the planet open or knock it out of orbit. So no, firing every nuke on Earth at Mars would not blow it up, split it in half, or knock it off course. Mars would still be there, still exactly where it was. So if the planet survives, what does the ground look like afterward? If the warheads were spread out across the surface, rather than clustered in one spot, you'd get thousands of massive craters, some of the largest impact-style scars ever created by human hands. Each detonation would vaporize rock, kick up enormous dust plumes, and, because Mars has almost no atmosphere to slow anything down, that debris could travel incredibly far and stay suspended for a long time. If, instead, all 12,000 warheads were detonated in one concentrated area, you'd get a single crater potentially miles wide and extremely deep, dramatic, violent, and instantly lethal to anything nearby, but still just a scar on a planet-sized body. Either way, no shattered planet, no dramatic explosion visible from Earth with the naked eye, just craters. Now here's where this gets genuinely surprising. A real scientist has seriously proposed detonating nuclear weapons on Mars, but not to destroy it, to warm it up. The idea, floated publicly by SpaceX founder Elon Musk, involves detonating nuclear weapons repeatedly over Mars's poles, not on the surface, but as air bursts above the frozen carbon dioxide ice caps. The goal would be to vaporize the frozen CO2 into gas, thickening the atmosphere and triggering a greenhouse effect that could, in theory, gradually warm the planet toward habitability. This idea is controversial and heavily debated among scientists, partly because Mars's polar ice caps likely don't contain enough frozen CO2 to meaningfully thicken the atmosphere this way, and partly because of the sheer number of detonations and long-term radioactive contamination it would require. So the strange truth is, humans have already seriously discussed nuking Mars, not as a weapon, but as a terraforming tool. Just not in the fire everything at once way this video started with. So if you pointed a telescope at Mars the week after this hypothetical event, what would you actually see? Not a shattered planet, not a fireball visible from Earth. You'd likely see a planet-wide haze from dust kicked into the thin atmosphere, some new dark scarring where major detonations happened, and possibly a slightly different color tone as fine dust settled across the surface. Within months to years, Martian wind patterns and existing dust storms would likely start smoothing over some of the smaller craters, the way Mars already does with impact sites today. The bigger scars, though, would probably remain visible in satellite imagery for a very long time, silent, permanent proof of what happened. And somewhere in that irony is the strangest twist of all. The same weapons capable of ending civilizations here on Earth might one day be seriously proposed as tools to help us live on Mars.